Good morning, students. So today we will continue our topic partial differential equation. In earlier last class we discussed Lagrange's equation, how to solve Lagrange's equation using method of grouping. So now today we will discuss another method to solve Lagrange's equation using method of multipliers. I already explained you two methods, one is method of grouping, another one is method of multipliers. Okay. So how to solve Lagrange's equation using method of multipliers and when to solve this method, just see here. Okay. So first what is our auxiliary equations? Auxiliary equations A is dx by capital P is equal to dy by capital Q equal to dz by capital R. These are our auxiliary equations to solve Lagrange's equation. Okay. When what is method of grouping method? We have to take any two equations and we need to integrate and we have to find C1 and C2, correct. So that is if variable separable is possible. If PQ are combinations of x, y and z, if PQ are combinations of x, y and z, then it is not possible to integrate using method of grouping. So for those type of sums we will solve method of multipliers method. So what we have to do in method of multipliers method, you need to multiply numerator and denominator. You need to multiply numerator and denominator with constant or variable. You need to multiply numerator and denominator with constant or variable, and you need to add all numerators and all denominators or subtract all numerators and denominator. In the way your denominator should become 0. That means what I am doing here, I am multiplying numerator and denominator with L, and here I am multiplying numerator and denominator with M. Here I am multiplying numerator with denominator with numerator and denominator with N. So what my each ratio becomes? Each ratio equal to LDX by LP equal to MDY by MQ equal to NDZ by NR. So what I did here, I multiplied numerator and denominator with L, I multiplied numerator denominator with M, I multiplied numerator denominator with N here. Okay. So what I am doing here, what we have to do, you have to add or subtract. What you have to do, you have to add or subtract. So each ratio, how we have to take LDX plus MDY plus NDZ by LP plus MQ plus NR. You need to add, here we are adding, you can subtract also according to your convenient, and according to your convenient, what is our target? You need to make this LP plus MQ plus NR become 0. So add or subtract, I will write otherwise, try to make LP plus MQ plus NR equal to 0. Try to make LP plus MQ plus NR equal to 0. So therefore anything by 0 will become infinity, but it is not the solution. What you need to do, you need to cross multiply this 0 this side. So 0 into each ratio becomes 0. So you will get LDX plus MDY plus NDZ form. Then you integrate, you will get the constant C1, and for the another case also say multiply with the other constants and integrate, you will get constant C2. Okay. So this is the method of multipliers. What we have to do, when grouping is not possible, when method of grouping is not possible, you need to use method of multipliers. Thus we will discuss in the problems. So what we have to do in method of multipliers, multiply numerator and denominator with L, and first ratio, second one M, third one with N. Add or subtract in the way your denominator should become 0. Okay. Let us resolve the one example problem. Okay, now we will see one example problem, or one problem we will see. Solve x into y minus z into p plus y into z minus x into q is equal z into x minus y. Okay. So what we have to do here, first we need to compare this given equation with Lagrange's equation. What we need to do here, first compare given equation with Lagrange's equation. What is our Lagrange's equation? So right here, compare compare given with Lagrange's equation. What is Lagrange's equation form? Capital P into small p plus capital Q into small q equal to capital R. So what is my capital P becomes here? So capital P is equal x into y minus z. What is my capital R becomes, sorry, capital Q. What is my capital Q becomes y into z minus x, and what is my capital R? Z into x minus y. Okay. So we compared given equation with Lagrange's equation, and we got the values of capital P, capital Q, capital R. Now what we have to do? You have to write auxiliary equations. What are auxiliary equations? Dx by capital P equal to dy by capital Q equal to dz by capital R. So this implies substitute our values. Dx by capital P. What is capital P? X into y minus z. Dy by capital Q. What is capital Q? Y into z minus x, and dz by capital R. What is capital R? Z into x minus y. Correct? So in method of grouping, you need to take any two and you need to integrate. If I take using method of grouping 1 and 2, what happened here? Here after that you need to integrate, right? So what happened here? Here we have dx and dy. That means you need to integrate with respect to x, and here you need to integrate with respect to y. So what happened? When we are integrating with respect to x, we have here y terms and z terms. It is not possible. So here also, if we integrate with respect to y, we have z terms and x terms. It is not possible to solve method of grouping. So in this case, we have to use method of multipliers. So what to do here? So using method of multipliers, what I am doing, each ratio. So each ratio, that means 1, 2, 3. So each ratio you can write any one, each ratio. For example, you take any one, x into y minus z is equal. Now what I am doing here, I am adding, simply adding all the numerators, all the denominators, or multiply numerator and denominator with 1. Multiply numerator and denominator with 1. Multiply numerator and denominator with 1. Okay. So what I get here? 1 dx plus 1 dy plus 1 dz by, then 1 into xy minus xz plus yz minus yx plus zx minus zy. Correct? What we did here, using method of multipliers, we multiplied numerator and denominator with 1, and we are multiplying even here, and we are adding all numerators, all denominators. So now see here what I told you, our denominator should become 0. Our denominator should become 0. Now let us see whether it is going to 0 or not. So xy plus xy minus xy got cancelled, minus xz plus xz got cancelled, plus yz minus yz got cancelled. So therefore this is equal dx plus dy plus dz by 0. So what I got here? So my denominator become 0. So this cross multiply this 0 this side, cross multiply this 0 this side. What we have in the left hand side? We have each ratio. That means any one, each ratio 1, 2, 3. So for example, I took only one. You can write second one, you can write third one, any one. So 0 into anything becomes 0. So therefore 0 is equal dx plus dy plus dz. Correct? Now you need to integrate. If I integrate here, integrate. So what is integration of dx? X. Integration of dy y. Integration of dz is equal to z. After integration, let us take constant c1. So I got first constant c1. Understand here how we did? We took auxiliary equation. We wrote capital P, capital Q, capital R values, and method of grouping is not possible. Method of multipliers we are using here. We are multiplying numerator and denominator with 1, and for this case same 1, and here also with 1. We are adding numerators as well as denominators in the way to get 0. Okay. Now for C2. Now for C2. Okay. So now I got C1. Now for another to find C2. So what I am doing now, each ratio. So for second case, each ratio, what I am doing here, each ratio, I am taking this x into numerator. I am writing this x into numerator. That means dx by x, and here I am writing this y into numerator plus dy by y, and here I am taking this z to numerator I get dz by z. Denominator mein we have to add remaining part. So y minus z plus z minus x plus x minus y. So plus y minus y got cancelled, minus z plus z got cancelled, minus x plus x got cancelled. So our denominator became 0. So therefore, what I got? Dx by x plus dy by y plus dz by z by 0. So cross multiply this 0 this side. So what we have here? We have each ratios, right? These three ratios are there. So 0 into anything becomes 0. This is equal dx by x plus dy by y plus dz by z. After that, you need to integrate. If I integrate here, integration of 1 by x is what? Log x plus integration of 1 by y is what? Log y. Integration of 1 by z is what? Log z equal to constant, take it as log C2. So earlier we used the formula log a plus log b plus log c will become log a b c. That means we have x y z equal to log C2. So my log and log got cancelled. I got the value x y z is equal to C2. So we obtained C2 value. So here we got C1 value and here we got C2 value. Whereas here we multiplied and to numerator and denominator by 1. Here we simply took the denominator x, y, z into numerator and we added the rest over the part. So therefore, what is our general solution? Phi of C1 comma C2 is equal to 0. Phi of what is my C1? I got x plus y plus z. What is my C2? I got x, y, z equal to 0. Okay. So no problem, you can write which one is first. If you solve this one is first, you can write it here first. If you solve that one is second, you can write it here. That is, nothing will happen with that. You can solve any one first, but only thing is what? You need to separate it with two methods. You can't write same thing again here and same answer cannot be come. Okay. This is the method of multipliers. Okay. So I hope you understand this method. So let us see another problem. So similar like this only. Now only change here x square, y square and z square. So earlier we did with x, y, z. Now we are doing x square, y square, z square. So what happened here? Compare given with the Lagrange's equation. So capital P into small p, capital Q into small q equal to capital R. Okay. So what is my capital P becomes x square. What is my capital Q become y square into this, and what is my capital R becomes z square into. Okay. Don't write in the notes like this. Do it in the other problem. Okay. I am here solving and that because it is similar problem. Okay. Now auxiliary equation dx by p, dy by q, dz by r. So here get square, square and square. Correct. Now how to make 0 here? Instead of multiplying, this part will change. Now what we have to do? So method of grouping is not possible here. Method of multiplier we have to use each ratio, or okay, we will take each ratio only. Each ratio. Okay. Each ratio equal to, now we need to add or subtract these three ratios. Okay. What we have to do here? Earlier in the previous problem we took denominator into numerator. So similarly here also same thing. You take this denominator into numerator. What I get here? Dx by x square plus dy by y square plus dz by z square. So what is my rest? What is my leftover part? Y minus z plus z minus x plus x minus y. So plus y minus y got cancelled, minus x plus x got cancelled, minus z plus z got cancelled. So therefore this is equal dx by x square plus dy by y square plus dz by z square by 0. So cross multiply this 0 this side. So 0 into each ratio. That means these three ratios becomes 0. So 0 is equal 1 by x square into dx plus 1 by y square into dy plus 1 by z square into dz. After that what we have to do? You need to integrate. So integrate here, integrate. So integration of 1 by x square is what? Minus 1 by x. 1 by y square is what? Minus 1 by y. 1 by z square is what? Minus 1 by z equal to, you take minus c1. Take minus c1. Then multiply both sides by minus. So what I get here? 1 by x plus 1 by y plus 1 by z equal to C1. Okay, that is my first constant value. Understand here what we did here? We took this x square into numerator and from here y square and here z square and we added the leftover part. So, we got 0. So, basically what is our target? The denominator should become 0. The denominator should become 0. So, after that we integrate, we cross multiplied that 0. 0 into each ratio becomes 0. Then integrate, you will get C1 value. Now, for another one C2. For another one C2, what we have to do? Each ratio, earlier you took x square, now you take only 1x. So, okay, I will write it here. So, if I take 1x to numerator, what is left here? X is left here. So, I will get here xy minus xz and here take 1y, then 1y is left. So, what I get here? Yz minus yx and here 1z go to numerator. So, what I get here? Plus zx minus zy. So, minus plus xy minus xy got cancelled, minus xz plus xz plus yz minus yz got cancelled. So, my denominator became 0. So, cross multiply this 0 that side, you will go for 0 like the same previous problem. You will get dx by x, dy by y, dy by dz by z. So, integration of 1 by x is log x, integration of 1 by y is log y, integration of 1 by z is log z. Take the constant log C2. Log a plus log b plus log c will give you log a b c. Both sides log got cancelled. So, general solution. What is my general solution? Phi of C1 comma C2 is equal to 0. Now, C2 is same. C1 becomes 1 by x plus 1 by y plus 1 by z. That is it. Okay. So, only thing is what you need to understand how to make this denominator 0. You can add, subtract, you can multiply or you can divide, but the target is you need to make 0. Okay. So, now let us see for one more problem. Now, problem number 3, solve px minus qy is equal to y square minus. So, px minus qy equal to y square minus x square. So, what we have to do? Compare given with Lagrange's equation of the form capital P small p plus capital Q into small q equal to capital R. Okay. So, what I get here? Capital P becomes small x, capital Q is minus y and capital R is y square minus x square. Okay. Now, quickly write auxiliary equations. So, what I get here? Dx by capital P equal to dy by capital Q equal to dz by capital R. Now, substitute my values. Substitute our values. Capital P is x, capital Q is minus y, capital R is y square minus x square. Now, observe this. So, here first two equations are possible to integrate method of variable and separable. Okay. So, you can take first two from 1 and 2, from 1 and 2. So, dx by x equal to minus dy by y, right. Now, integrate here. If I integrate here, 1 by x integration is what? Log x equal to minus 1 by y integration is what? Log y. Constant take it as log C1. So, log a minus log b will give you log a by b, C1 by y. So, both side log and log got cancelled. Cross multiply this y, xy is equal to C1. So, we got C1 value using method of grouping. Now, solve C2. To solve C2, what happened? If I take 1 and 3, here it is okay, but here what happened? You need to integrate with respect to z, but we have y and x terms. If I take 2 and 3, here it is okay. If here what happens? Same again, you need to integrate with respect to z, but here we have y and x. Okay. So, now this to solve, now to find C2, you have to use method of multipliers. So, what we have to do for method of multipliers? Each ratio, I am taking each ratio equal to, I am multiplying first term, first ratio with the x dx and x dx, denominator become x square. Second one multiplying numerator denominator with y dy plus into minus y square, and third one as it is with the 1. So, dz plus y square minus x square. If you want, you can write it here in the bracket. First one with x, second one with y, and third one with 1. X, we multiply numerator and denominator with x to first ratio. Second one, we multiplied numerator and denominator with y, and third ratio we multiplied numerator and denominator with 1. This is nothing but our LMN, not required, only for your understanding purpose. Okay. So now what happened? See here, my this is x square. Now what happened? X square got cancelled, minus y square plus y square got cancelled. So therefore this is equal to each ratio x dx plus y dy plus dz by 0. Correct? So cross multiply this 0, we have each ratio. That means we have 3 ratios here. So 0 into anything becomes 0 equal x dx plus y dy plus dz. Now integrate here. If I integrate, integration of x is what? X square by 2. Integration of y square by 2. Integration of dz is equal C2. Right? You got C2. So first one we obtained using method of grouping. Second one we obtained using method of multiply. So therefore general solution phi of C1 comma C2 is equal to 0. Phi of, what is my C1? xy. What is my C2? X square by 2 plus y square by 2 plus z equal to 0. That's it. Okay. Okay. Sum number 4. Solve mz minus ny into p plus nx minus lz into q equal to ly minus mx. So compare given with Lagrange's equation. So capital P value, capital Q, and my capital R becomes ly minus mx. Okay. So quickly, what are my auxiliary equations? Dx by capital P, dy by capital Q, and dz by capital R. That means dx by, what is my capital P here? Mz minus ny, dy by, what is my capital Q? Nx minus lz, dz by, what is my capital R? ly minus mx. ly minus mx. Okay. So now see whether can we solve using method of grouping? Check it. It's not possible because we have combinations here. So method of grouping is not possible. So we need to solve using method of multipliers. So what I am doing here, each ratio. So each ratio is equal to, what I am doing here, I am multiplying numerator and denominator with L here, and here I am multiplying numerator and denominator with M. Here I am multiplying numerator with the denominator with the n, and we are I am adding all the numerators and all the denominators. So what I get here, L dx plus m dy plus n dz by, so multiply, already multiplied by L. So here also with L I get lmz minus lny, and here with m, mnx minus lmz, and here with the n, lny minus mnx. So let us see whether it is going to 0 or not. Plus lmz minus lmz got cancelled, minus lny plus lny got cancelled, mnx minus mnx got cancelled. So that means this is equal ldx plus mdy plus n dz by 0. So cross multiply this 0 this side. So 0 into anything becomes 0. So 0 equal to ldx plus mdy plus n dz. Now what we have to do? We need to integrate. If I integrate here, so integration of L is constant with respect to x. So Lx I get here my and here nz equal to C1. So I got my C1. Now what we have to do? You need to find C2. For C2, what we have to do? Same again, each ratio equal to. Now this time you multiply numerator and denominator with x, you multiply numerator and denominator with y, you multiply numerator and denominator with z. Simply you remember, here we have 3 variables L, M, N, and here x, y, z. So here there is no L. So first case we multiplied L, here there is no M, we multiplied M, and here there is no N. Now x, y, z are there, here there is no x, and here there is no y, and here there is no z. So each ratio becomes, I am multiplying numerator and denominator with x to first part, second part with y, and third ratio with the z, right. So the same in the denominator also, I get mxz minus nxy plus nxy minus lyz plus yz minus mxz. Okay. So my plus mxz minus mxz got cancel, minus nxy plus nxy minus lyz plus lyz got cancelled. So therefore each ratio, my denominator became 0 here. So x dx plus y dy plus z dz equal to 0. Correct? So cross multiply the 0 this side. So 0 is equal to x dx plus y dy plus z dz. Now what we have to do? We need to integrate here. Integrate. If I integrate here, integration of x is what? X square by 2. Integration of y is what? Y square by 2. Integration of z is what? Z square by 2. Take the constant c2 by 2. 2 got cancelled. So x square plus y square plus z square is equal c2. So therefore general solution phi of c1. What is my c1 becomes lx plus my plus nz comma c2. What is my c2? X square plus y square plus z square is equal 0. Okay. Okay. Here you write first of all phi of c1 comma c2 is equal to 0. Then you substitute c1 comma c2. Okay. So very very important. Mentioning general solution is very very important. Understand this method. So you need to, in first case we multiplied with L, M, N, and second case we multiplied with x, y, z. Okay. This is the method of multipliers. Okay. Sum number 5, solve small p plus 3q equal to phi z plus tan of y minus 3x. Okay. So compare given with Lagrange's equation. So what I get here, my capital P is nothing is there, so I will take 1, capital Q is what? 3, and capital R becomes, what is my capital R? Phi z plus tan of y minus 3x. Okay. Now auxiliary equations. So quickly write here, what is my P? Q and Z, R, right? Okay. So first take, see first two equations. So it's very easy to integrate. So you can use method of grouping here. So let us take 1 and 2 from 1 and 2. So what is my 1? Dx equal to dy by 3. So cross multiply 3 dx equal to dy. Now integrate here. If I integrate here, integration of dy, first integration of dx x, and take constant here this side, and integration of dy is y. We can take constant here or here, no problem. Okay. So c1 equal to y minus 3x. Why I took constant here this time? Because here we have y minus 3x, correct? Here we have y minus 3x. So for that, so I got y minus 3x value as constant c1. So I got c1. Now what you have to do? You need to find c2. So for c2, now 1 and 2 is over. If I take 1 and 3, what happened here? Dx and here dz, but we have y terms, correct? It is not possible to integrate with respect to x or z to y terms. Now if I take 2 and 3, what happened? Here y is there and here z is there, but here we have x terms. So to eliminate this y minus 3x term, what I took here? Constant this side. So I got y minus 3x value as c1. Now I am taking, I can take 1 and 3 or I can take 2 and 3. So let us take 2 and 3 from 2 and 3. So what is my equation 2? Dy by 3. What is my equation 3? Dz by 5z plus tan of, what is my y minus 3x value? Is c1. So I am writing here c1. So you can integrate easily now. So now integrate here. If I integrate, integration of dy is what? Y, and this is in the form of 1 by x. 1 by x integration is what? Log x, log 5z plus tan c1. Again chain rule differentiation of 5z. Z is 1, I will get 5. So 5 will come here plus c2. So cross multiply this 5, or you can write like this. Total term you bring it this side. So y by 3 minus log of 5z plus tan c1 by 5 is equal c2. Okay. So therefore I got c1 and c2, general solution phi of c1 comma c2 is equal to 0. Phi of, what is my c1? I got y minus 3x comma, what is my c2? I got y by 3 minus log of 5z plus tan of tan of C1. What is C1? Y minus 3x whole divided by 5, okay, equal to 0. That's it. Like this you have to solve this problem, okay. So, based on this we complete this session. I will give you 2-3 problems for homework. So, let us see. So, we completed that problem. Now, you take these 2 problems for homework. So, what is the first problem? Solve x into y square minus z square into p plus y into z square minus x square into q is equal z into x square minus y square. So, using Lagrange's equation in that method of grouping or method of multipliers. Try to solve these two problems and send me the mail. If you have any doubts, please send me the mail, okay. So, if you didn't get, no problem, I will explain in another video those all problems, whatever the problems are given to you in homework, okay. Let us will complete this session today and we will meet in the next class again. Thank you.